Imagine for a moment that you are standing alone at the edge of a frozen lake at midnight. The air is so still and so cold that the silence itself feels like a physical weight pressing down on your eardrums. Above you, the sky is a perfect crystalline dome of stars, so many stars that the darkness between them seems to have been erased. You look down at the ice beneath your feet. It is opaque, milky, and solid. It feels like the definition of inert, dead matter. You are certain of its stillness. Then you kneel down and place your ear against its surface. At first there is nothing, just the cold biting your skin, but you wait, you focus, and then you hear it. A low, resonant groan, a deep, organic-sounding pop, a series of sharp electric cracks that race across the frozen plain, vanishing into the distance. The ice is speaking. It is moving. It is, in its own way, alive with stress and pressure, and the fundamental forces of the universe. It is responding to the world, changing its shape, singing a song of physics that you can only hear when you are close enough to listen. Now look back up at the night sky, at those pinpricks of light that seem as static and eternal as the ice once seemed. They are not just lights, they are furnaces, they are engines, and the space between them, we call it a vacuum, we call it nothing. But what if we have just been standing on the ice, looking at the stars without ever putting our ear to the ground? What if the silence we assume is just a limitation of our senses? What if the universe isn't a grand clockwork mechanism that's winding down, but something else entirely? What if it's breathing? This is the question that haunted the mind of Richard Feynman. Not in a mystical, New Age sense. Feynman had a famous disdain for anything that couldn't be tested or observed, but in a deeply physical, logical, and utterly provocative way. He looked at the cosmos not as a collection of dead objects moving through empty space, but as a dynamic, interconnected system where the line between a thing and its environment, between a rock and the void, between life and non-life, becomes startlingly, beautifully blurry. To understand what Feynman saw, we have to stop thinking like humans for a moment. We have to abandon our biological definition of life. We think life is about DNA, reproduction, metabolism, growth. We look for these signatures on Mars or the moons of Jupiter, but what if we're looking for the wrong thing? What if we're expecting the ice to be warm? Think about a flame, a candle flame. Is it alive? Watch it for a while. It breathes, doesn't it? It draws in oxygen from the air and exhales carbon dioxide and water vapor. It metabolizes fuel, the wax. It grows and changes shape. It responds to its environment. Poke it and it flinches. It even reproduces in a way. One flame can light another, passing on its essence without passing on a single molecule of the original wax. A flame has a structure, a defined boundary where it meets the world. But we don't call it alive. We call it chemistry. We draw a hard line. Feynman would look at that line and ask, why? Why is a complex chemical reaction that sustains itself, responds to stimuli, and propagates itself considered merely a process, while a bacterium that does the same thing is considered a life form? Is it just a matter of time and complexity, or is there a deeper principle at work that applies to stars and galaxies just as it applies to forests and ecosystems? Let's conduct a thought experiment, the kind Feynman loved. Imagine you are shrinking yourself down, smaller than an ant, smaller than a cell, smaller than a molecule. You are now swimming in the microscopic world of a living cell. You look around. What do you see? You don't see a life force. You see molecules. You see proteins shaped like crazy origami bumping into each other. You see ions flowing through channels. You see strands of DNA, which is just a coded data storage molecule, being unzipped and read by other molecules. It's machinery, it's physics, it's cause and effect. A molecule bumps into another molecule, and because of their shape and electrical charge, they lock together. A chemical bond forms, energy is released, and a new molecule drifts away. There is no ghost in the machine. There is only the machine. Now zoom out. Blast back out to your normal size. The cell is still there. It's still alive. Nothing changed in the physics. The only thing that changed was your perspective. The aliveness wasn't a property of the individual molecules. It was a property of their organization. It was a property of the pattern. This is the key that unlocks Feynman's view of the cosmos. He saw the universe as a grand exercise in pattern formation, and the most fundamental, pervasive pattern in the universe is not a spiral or a circle. It is a process that takes in energy, uses it to create order, and then expels the waste. It's called a dissipative structure. Think back to the flame. The flame is a perfect example of a dissipative structure. It only exists because it is dissipating energy. It takes the high-energy chemical bonds in the wax and the oxygen, breaks them down, and releases lower-energy heat and light. The flame is a temporary island of order, created by the flow of energy from a source, the wax, to a sink, the cooler air around it. Without that flow, the flame vanishes. It isn't a thing. It's a process made visible. Now, look at a hurricane from space. It is a colossal, terrifying structure. It has an eye, a wall, spiral bands. It lasts for weeks, moving across the ocean. It has a kind of metabolism, feeding on warm, moist air. It dissipates energy on a massive scale. Is it alive? No, we say it's a weather system, but it follows the same physical rules as the flame. It is a pattern of matter and energy that persists by consuming and dissipating energy. Now look at a star, our sun. For 9 billion years, it has been a roiling, seething ball of plasma. Deep in its core, in a volume the size of 1,000 Earths, gravity is crushing hydrogen atoms so violently that they fuse together, becoming helium. In that process, a tiny fraction of mass is converted into an unimaginable amount of energy. This energy fights against gravity, trying to explode the star outward. For billions of years, they have been locked in perfect balance, a stalemate between the force of collapse and the fury of fusion. The sun is a dissipative structure of staggering proportions. It is a temporary pocket of order, a sphere of plasma, created and maintained by the flow of energy from the nuclear furnace in its core to the freezing vacuum of space. It takes high-density mass and radiates it away as light and heat. It is not just a ball of burning gas. It is a process. It is a system that has found a way to sustain itself for eons by riding the gradient of energy, from the intense concentration in its core to the diffuse emptiness around it. This is where Feynman's perspective becomes truly radical. If a cell is a network of chemical reactions, a star is a network of nuclear and gravitational reactions. If a cell has a boundary, its membrane, a star has a boundary, its magnetosphere and heliosphere, a vast bubble of solar wind that pushes back against the interstellar medium, actively shaping its environment. If a cell responds to stimuli, the sun has an 11-year cycle of sunspots, a kind of heartbeat driven by the churning, twisting plasma within it. It isn't a static object. It's a living system in the sense that it is a dynamic, self-regulating pattern. But the sun is just one star, and the galaxy, the Milky Way, is home to 400 billion stars. And they are not just scattered randomly like salt on a table. They are organized. They orbit a supermassive black hole at the center, a gravitational anchor. They move in waves like a stadium crowd doing the wave as density fluctuations ripple through the spiral arms. Stars are born in vast nebulae, live their lives on the main sequence, and die, seeding the galaxy with heavy elements, carbon, oxygen, iron, the very stuff of planets and people. These elements are then gathered up into new clouds of gas and dust, and the cycle begins again. The galaxy, too, is a dissipative structure. It is a pattern of matter and energy, a colossal system that ingests diffuse clouds of hydrogen and over billions of years processes them through stellar alchemy, turning them into heavier elements and radiating the energy away into the cosmic microwave background. It is a system that creates order, spiral arms, globular clusters, planetary systems, out of the primordial chaos of the early universe. It is a system that breathes on a timescale so vast that our entire recorded history is less than a single heartbeat. Now we come to the void itself, the space between the stars. We call it a vacuum, and we think of it as the ultimate nothing. But a vacuum, as Feynman knew better than almost anyone, is not nothing. It is the stage upon which everything is played, and the stage itself is seething with potential. Quantum mechanics tells us that at the smallest scales, the vacuum is a frenzy of activity. Particles and antiparticles, electrons and positrons, quarks and antiquarks are constantly winking into existence and annihilating each other in a span of time so short we can't directly see them. They are virtual particles, borrowing energy from the universe to exist for a fleeting instant. This isn't just a mathematical trick. It has measurable effects. It slightly alters the energy levels of electrons in atoms, a shift known as the Lamb shift, which Feynman helped explain. It creates a force between two metal plates placed close together in a vacuum, a force called the Casimir effect, which pushes them together because there are fewer virtual particles between them than outside them. The vacuum is not empty. It is the quantum foam. It is the substrate of reality. It is the potential for everything, and it is interacting with the real particles of the universe constantly. Every electron, every proton is dressed in a cloud of virtual particles, constantly exchanging them with the void. You are not separate from the vacuum. You are in constant, intimate dialogue with it. Your very existence perturbs the nothingness, and the nothingness in turn shapes you. Feynman visualized this with his famous Feynman diagrams. These simple line drawings show particles interacting, moving forward and backward in time, exchanging ghost-like virtual particles. They are a map of the conversation between matter and the void. They show that the universe at its most fundamental level is not a collection of static billiard balls, but a web of relationships, of exchanges, of constant dynamic interaction. The stuff of the universe, the quarks and electrons, are just the nodes in this web. The web itself is the reality. So let's step back. We have a star, a self-sustaining pattern of nuclear fire. We have a galaxy, a city of stars, recycling matter. We have a quantum vacuum, a frothing sea of potential that underlies and connects everything. Now, look at the entire cosmos. The universe itself is expanding. The galaxies are flying apart. This expansion is not an explosion into existing space. It is the stretching of space itself. And this stretching is a form of work. It's a flow of energy. The universe began in a state of impossibly high density and energy, the Big Bang. For 13.8 billion years, it has been expanding and cooling, dissipating that initial unimaginable concentration of energy into the vast, cold, empty space it creates as it goes. It is itself a dissipative structure. It is the ultimate dissipative structure. It is a process of energy flow on the largest possible scale. It took the primordial chaos, and through the forces of gravity and thermodynamics, forged galaxies, stars, planets, and eventually you. You are not just in the universe, you are a part of the universe, a tiny, intricate, fleeting pattern of matter and energy that the universe has created as a way to experience itself. The iron in your blood that makes your heart beat was forged in the core of a star that died billions of years before the earth formed. The calcium in your bones, the oxygen you breathe, the carbon that forms the backbone of your DNA, every atom in your body heavier than hydrogen and helium was manufactured in a stellar furnace and scattered across the galaxy by a supernova explosion. You are literally made of stardust. But more than that, you are a continuation of the star's process. The star existed to fuse hydrogen into heavier elements. Those elements now exist in you, arranged in such a complex pattern that you can ponder the star that made them. You are a way for the universe to become conscious of itself. You are a localized, temporary reversal of entropy, a pocket of incredible order, maintained by the constant flow of energy. The food you eat, which ultimately comes from the sun, a star, and dissipating that energy back into the environment as heat. So, is the universe alive? If by alive we mean having a heartbeat, a metabolism, or DNA, then no, of course not. But Feynman would urge us to look deeper, to see the patterns beneath the surface. The universe exhibits behavior that is strikingly analogous to life. It is dynamic, not static. It is organized, not chaotic. It recycles its components. It creates increasing complexity over time. It is a self-sustaining system of energy flow. It has a history. It learns, in a sense, through the process of cosmic evolution. Gravity learned to form galaxies. Stars learned to fuse carbon. Planets learned to become platforms for chemistry. The question isn't really a scientific one, because science can't define life in a way that includes a star and excludes a fire. The question is a philosophical one, a perspective shift. It's about choosing which lens to look through. Remember that frozen lake. You put your ear to the ice and heard it groan and crack. You realized that the solid, dead object was actually alive with stress and strain. Now, put your ear to the sky. Not literally, but metaphorically. Listen with your mind, with the tools of physics. Listen to the nuclear fusion humming in a million cores. Listen to the whisper of virtual particles in the vacuum. Listen to the slow, inexorable pull of gravity, sculpting matter over billions of years. The universe is not a silent, static void. It is a symphony of processes. It is a vast, interconnected system of energy and matter, constantly changing, constantly becoming. Perhaps we have been asking the wrong question. Perhaps the universe isn't alive. Perhaps we and everything we consider alive are just one of the ways the universe has of being itself. The question, is the universe alive, flips the perspective. It makes the cosmos the subject and us the predicate. But the more profound truth, the one that Feynman's relentless curiosity points to, is that the boundary between the subject and the predicate, between the living and the non-living, between the observer and the observed, is not a wall. It's a membrane. It's permeable. It's a dance. You are not a stranger in a foreign land. You are not a passenger on a ship sailing through dead space. You are a wave in an ocean. You rise for a moment, catch the light, feel the wind, and then you merge back into the depths from which you came. The ocean does not live. The wave does not live. The process of the ocean, the rising and falling, the currents and the tides, the evaporation and the rain, that is the dance. And you are a part of that dance. So the next time you look up at the night sky and feel small and insignificant against the vast, cold darkness, remember the ice. Remember that the silence is just a frequency you cannot yet hear. Remember that you are not looking out at something dead and distant. You are looking at your past. You are looking at your constituent parts. You are looking at the engine that built you. The universe is not a stage on which the drama of life plays out. The universe is the drama. And for a brief, shimmering moment, you are one of its leading players, conscious of the script and capable of looking up in wonder at the rest of the cast. And that perhaps is more extraordinary than anything we could ever hope to find.